Okay, so first of all, a little background. The first week of the Feather Lab that we do in ME30 is composed of two parts. There's typically a walkthrough demo that I do at the beginning of the lab, which usually takes about 45 minutes or an hour. And then the rest of the lab is kind of the typical lab that you're used to, where you sit down, you write code, you try and figure it out on your own, you ask your TA if you need any help, and you turn in an assignment the following week. So the first part of the lab is what I'm calling the Lab9 warm-up. Warm-up being, this is the part of the lab where we get your software all set up on your machine, your laptop, and you plug your kit into your laptop so that by the end of the lab, you walk out with your kit and your laptop working well together so that you can go home and you can do the rest of your labs and the rest of your homeworks for the rest of the semester on your own. And you don't need to be tied to, for instance, the lab PCs. So what I typically do in all past semesters is I pretty much show up for every lab session and I get people going, and that's what I do. So the way that this worked this semester, obviously I can't be there in person because of the plague that's going around. So what I'm going to do is I'm doing this video, and what the intent is to walk you through the warm-up part of the lab. So strictly speaking, this video is not necessary because the lab itself, the warm-up part of the lab, describes all the steps. So this is really only for people who are confused about how all this fits together and would really, really like to see it in action rather than just read through the lab, look at the pictures, and try and figure it out. Now, there's a possibility that I'm going to mention some things in this video that aren't written up in the lab, and I'm not necessarily going to just read out the contents of the lab that's already been written. So for the most part, you should really only need the lab, but this is here just for a backup. So what you see here is you actually see that two kits. This is last semester's kit here, and this is this semester's kit. Now I'm going to have to talk about the old kit for part of the lab, not very much, because there are probably about half a dozen students that have last semester's kit. There's not a big difference between the two, but where there are differences, I'll call those out especially, and we'll either take a detour and talk about the 1.0 version of the kit or the 1.1 version of the kit, which is the current semester's. By my best count, there's probably 6 or 7 students this semester, roughly 10 or 15%, that have last semester's kit. We always try and allow people to borrow kits from previous students, and 4 students this semester did buy a kit from me that were left over from last semester. So one thing you're going to see that may be different is that even if you have this semester's kit, you're going to notice that your kit doesn't have a laser pointer on it. I had 2 or 3 laser pointers left over from this semester because of the coronavirus thing. I didn't get laser pointers in time to be able to put them on your kits. I still don't have them, and it's already the first week of lab. I ordered them weeks ago. I just received something today in the mail, just today, literally, that I ordered on January 16th. And in fact, I have one order from January 2nd that I placed that I still haven't received yet. So things are really backed up coming from China. So if and when we get the laser pointers, if it's not too late, as I mentioned in the initial announcement, for the extra $4, I'll install the laser pointer on yours. All it really entails is I have to strip the leads on the wires, stick them into your spring-loaded connector here, hot glue the laser on, and align everything. And that's basically all it takes to get the laser pointers added, assuming we have the time and the logistics to be able to do that before the end of the semester. So as you can now see, this is the lab that we're going to walk through, the half of the lab that we're going to walk through. Feel free to pause the video or stop it entirely and go back and look at the lab. It's all up to you as to how you want to pace yourself with the written part of the lab in this video. But hopefully with the two of them together, there'll be no misunderstandings or anything that's unclear about how the lab kits work. So every time I take the camera off, I'm going to have to realign it, so forgive me. This is my fancy home studio setup. It is my cell phone with a piece of wood across two crates that I can put the camera on and use as an overhead. So nothing fancy, obviously. This is all I got. So let us talk first about what? Is there anything I want to preface the warm-up with? No, I already told you what the goals were. The goals were that by the end of this part of the lab, your kit and your software and your laptop are all set up to be able to use the kit. So that's the goal here. Keep that in mind. So the first part of the exercise is basically all you need to do is take your kit. I'm going to move this kit aside right now because we're not going to use it for a little while. So when you pull your kit out of the box, you're basically faced with this. You've got your USB connector here, and I'm going to have to unplug the other one from my file manager to show you realistically what this is going to look like. Let me find a file manager. Okay, so what we have here is my file manager. This is clearly Windows, and if you look, I've got my hard drive over there on C, and I happen to have a SD card plugged in as my E drive currently. So what happens is when you take your kit and you plug it into USB, and I actually hope it doesn't work the first time because this is a lesson in its own right. Okay, darn it. Okay, so it did actually come up. So when you power your board, you will see something like this on your screen. It's really annoying. This thing pops up sometimes multiple times. You get this, but when you plug your kit in, you will see a new drive show up in your file manager, and this is your volume called CircuitPy. This is actually the flash file system that is on your kit. So when you plug your kit in, your microcontroller board in, what happens is the board fakes like it's a USB flash stick. So the way to program your kit is to just drag and drop files from elsewhere on your laptop over onto this drive, and the board reprograms itself and starts running your program. And we're going to see this a little bit later in the lab. But when you plug your kit in so that it's going like this, you should see a CircuitPy volume show up. Now, one thing I will note is I kind of hoped it would happen when I plugged it in. I'm going to try it. Is that sometimes what happens is when you plug your kit in, rather than get this nice big bright LED here on, sometimes you only get this little yellow LED flashing. And what that is it's an indication that your USB, there we go. So this is what you might see. This is the indication that the USB isn't connected fully. I have this problem with my own kit every once in a while. It hasn't been acting up right while I've been shooting this video, but all you need to do typically is, now in that case I wiggled it around, which is surprising to me because that's usually not what I have to do. Usually I just have to unplug it and plug it back in again. But if you're not seeing this big LED right here come on, you're not getting power and data contact with your board from your laptop. So that's kind of the first lesson. What you should see and what you shouldn't see on your kit and in your file manager when you plug your kit in. If you're not seeing both the CircuitPy volume show up in your file manager and this LED come on, and you will probably never see one and not the other, but if you're not seeing both of those things happen, your board isn't plugged in correctly. If you plug it in multiple times and you don't get to this point, you may have a problem with your kit. So I guarantee when it went in the box, it didn't have this problem, but not so much in this course, but in 106, there are some things you can do that endanger your board through a more advanced use that you can actually fry a board. I rarely know of, or I rarely know of any students doing this in ME30. I don't remember anyone ever having to come back and buy another board for me. But every semester in ME106, I'll probably have 2, maybe 3 students go, yeah, you know, I went to plug in a wire into my board and I missed and I pressed it against something I shouldn't have and I fried my board. And I'll go, yep, that happens. So not so much a problem for this course, but I thought I'd mention in case it happens to you. Nothing to be too embarrassed about, but it will set you back another $29 to get another one of these boards. And the other boards, if for some reason you fry one of them, they're less than $29. They start at like $12 depending on which board it is that you toast. So let's carry on with the lab. I'm in the section of the smoke test. So I've pretty much shown you what you should see in the file manager. I didn't show you the actual contents of the CircuitPy drive, I don't think, but it's exactly like what's in the picture in the lab. It is, what you see is that. In fact, let me not cheat, and I'll actually show you what you should see. No, closed it. By the way, if you haven't noticed already, what happens when you are focused in the CircuitPy volume and file manager, and if you unplug your board, it takes away your file manager, so you have to start a new one. I'm sure that's what happened. So this is the contents of my CircuitPy volume. Zoom in a little bit there. There's a bunch of files on there. We'll talk more about them later. But this is what you should see. Let's go back to here because I like having my hands free. And so that is pretty much it for the contents of the smoke test section in the warm-up lab. So the next section is updating the demo files on your kit. So even though I have put a set of the demo program files on your kits before I put them in the box to you, they're already out of date. It's rarely a week or a couple of weeks go by where I don't improve that demo program or that test program that I use to test boards. And by this time, your kit files are already out of date, regardless of whether you have a 1.0 kit or a 1.1 kit. So the first thing we're going to do is we are going to update the files on your kit. So the way to do this is you start by just, I'm going to have to one-handed type here. You just go to your file manager. You go to your CircuitPy volume. I'm already there. And just select all the files and delete them. And then what you're going to do is you should have already downloaded the full demo version 1.0 zip file from the Canvas website for the course. If you haven't done that, go ahead and pause the video and go ahead and do that now. I'm going to see if I can't find mine here. This is all my ME30 stuff. So here's my zip file. So what I'm going to do is I'm going to double click on this guy. Here's all the files. What you can do is you can either unzip this and put it somewhere on your laptop, on your hard disk, or you can actually send them right to your CircuitPy volume. And never mind the sound of the cat meowing if you hear it. It's been a crazy time for him too. Okay, so once you do that, there's all the files from that zip file unrolled onto my CircuitPy volume, which is, like I said, the flash file system that's on the Feather board. So I know I've got the most recent version, and you can check this out too, because as of the time of this writing, version 1.0 is the most recent version of the code that's in code.py. And we'll be talking more about code.py very, very quickly. So that's all it takes to update the software on your CircuitPy volume, on your Feather board. Pretty darn easy. Compared to how microcontroller boards were programmed in the past, this is so much easier. I'm almost glad you don't know how difficult processes like this used to be on other boards. So one thing I point out here in the lab is I say note especially that what you want to see, now depending on how you unzip it, what you might see when you unzip it into CircuitPy is you might see a directory, and only a directory, and then if you go down into that directory, you'll see these files. That's not what you want. What you want to see is all these files up at the level of CircuitPy. Oh, okay, so somebody wants to be seen here. Yeah, you're grumpy. Okay, so what you want is all these files to be at the level of CircuitPy on your flash stick. And the cat is jumping around, and if everything crashes, you'll know what happened. Sorry about that, folks. Okay, so the files are where they need to be in the CircuitPy volume. So what you'll see is, you should see something like this on your kit. You should see the 2 red LEDs flashing on your board. If you don't, oh crap, that was exactly what I warned you about. The cat just crashed my setup here. Hang on. Damn it, Jamie. Crazy cat. Meow, meow. Okay, so now there's one thing we might as well talk about it now. There are 2 red LEDs on this board, and there's a red, green, blue LED in the center between the 2 push buttons. There's a little jumper here that spans 2 pins. There's 3 pins, so there's 2 combinations. You either use this jumper to join the top 2 pins or the bottom 2 pins. There's printed on the board, it actually says, I'm sure you're probably not going to be able to see it here, but it says red on the top and RGB on the bottom. If you want to use the red LEDs at any point, you put the jumper across the top 2 pins. If you want to use the red, green, blue, then you put it across the bottom 2 pins. In the course of running the demo, you're going to see us change that very, very quickly here. But I wanted to make sure initially you started in this position. So if your jumper isn't joining the top 2 pins where it says red, go ahead and do that now and get to the point where you should be seeing this. If you don't see this, then I would say go ahead and maybe unplug your kit and plug it back in again. That's the only thing I can think to do at this point. But so how you got to this point was on that flash file system, your CircuitPy volume, there is one of the files is called code.py. Code.py is the magic file. That is the program that is run whenever power is applied to the board. Anytime you change code.py, either by dragging and dropping a new copy over to your flash stick and over onto your CircuitPy volume and replacing it, or if you just use an editor and open whatever it is, code.py on your CircuitPy volume, every time you just write that new file out, the board recognizes that file's been changed and it reruns the program from the beginning. So if you have a simple little change you need to make in your code, all you need to do is change the characters in the source code, Control S to save it or hit the save icon, and it's automatically running the new version of your software. That's all it takes. It doesn't take a lot of other fancy processes to do it, including extra hardware. This is a magnificent system, and this is part of the reason why we're using this rather than any other hardware for you guys in ME30 from now on. I shouldn't say from now on. I don't know what's going to happen next year. No, I do know what's going to happen next year. It's going to be the same as this. A couple years out, who knows? But so assuming you've gotten to this point, the next part of the warm-up is to just install the software for the MU editor. Now, rather than using Jupyter Notebooks and Anaconda, we're going to use another editor which is specifically built for boards like this, and it automates a lot of the stuff that is just not available in Jupyter Notebooks. So the integration for Jupyter Notebooks just isn't there yet. At some point in time, it might be usable to be able to program and interact with this board, but at this point in time, that's not the case with Jupyter Lab. So we're going to use the MU editor. So MU, if you don't know already, is the Greek letter for micro, because MicroPython is the version of Python that we're running on this board. Actually, technically, it's called CircuitPython. It's an offshoot of MicroPython. So now's a good time to pause and use the link that's in the text for the warm-up lab to go and find the link from which you can download the software. And all the instructions in the text should make it pretty clear which version you need to get. Okay, so assuming you've unpaused and you've come back and gotten your Moo software running, I'm going to go ahead and I'm going to pop it up on my... Do I not have a copy of Moo running? Yes, I do. Okay, so this isn't exactly what you'll see. You'll actually see a skeleton piece of code here with like one comment in it that says, hey, this is where your code goes. The key point is that when you're interacting with the board, you should see CircuitPython or possibly Adafruit, depending on which version of Moo you downloaded. If you're using the 1.1.0 Alpha 2 version, it'll say CircuitPython. If you're running the 1.02, the previous build, the stable build, it'll say Adafruit there. So this is the point that you need to get to. It's also described in the text for the lab. Just to put something on the screen here that's a little more interesting, I'm going to go ahead and I'm going to open up code.py. In fact, this is probably the point in the write-up for the lab that it's going to ask you to do that. Yeah, it says now use the load icon to select code.py from your CircuitPy volume and suck it into Moo, which is what you just saw me do. So the next thing you're going to do is you're going to go and you're going to hit the serial icon. And what this does is this splits the window and gives you another window down here. So you may have thought already, so if I do a print in my Python program, where does it go? Well, clearly there's no screen on your kit. Maybe in the future, the kits will be fancy enough that they will have a screen on them, but cost for that is a little high. So what Moo does is it provides this other window called the serial window in which print messages go. So because I opened up the serial window after the serial the program started, we missed those messages. So as I just mentioned, if you focus on the the code.py window and you resave the file, right, the board recognizes that, oh, there's a new copy of code.py. It doesn't know that you didn't actually change it, by the way. If you just resave the file, the program starts again from the beginning. And these are the initial introductory messages that you missed when you didn't have the serial window open before the program started to run. So I'm going to walk you through the entire demo right now, and you should be able to be in a position to do this also on your kit, and we can do this at the same time. Feel free to go ahead and pause the video anytime you want to catch up or slow down, take a break, whatever. So the first command, the first order is to switch the LED jumpers to the red position, which we already did. We did that just a couple of minutes ago. And then press each button in any order to light its respective LED. Then press SW0 again to continue. So what this is telling me to do is, it wants me to press each button. I'll happen to press this one first. It lights the LED corresponding to that button. Then I'll press this one. So now I pressed all my buttons, all two of them. Whoopee. And then it says press SW0 again. Now this is SW0 and this is SW1. You can't see it because it's in the shadow. Maybe, there you go. So it says 0 right there and it says 1 right there. And SW stands for switch. So this is SW0 and this is SW1. For the most part, by name, we're only going to be using SW0 for the rest of this demo. But if in the subsequent part of the lab it mentions SW1, that's this guy over here to the right. Let me find it. There we go. So it's the last thing it said over here was press SW0 again to continue. So let's just go ahead and do that. So it's going to start doing this kind of funky pausing and kind of fading thing. But if you look back, you got a new prompt. It says switch the LED's jumper to the RGB position to use the, and see, what does it say there? I can't see because the camera's in the way. And see the RGB LED fade red, green, blue. Then press SW0 to continue. So I'm going to put the camera back up here. I'm going to switch the jumper as I was instructed from the red position to the RGB position. Okay. So, it's kind of washed out. Let's see if I can do this better. Yeah, so you can see that it's going red, green, blue. So for my purposes, that proves that the red, green, blue LED is soldered on correctly. The previous test proved that the buttons work and the two red LEDs work. And that's basically the goal of the test program that I run before I box up the kits and give them to you. The demo program that we're running is a variation of that test program. They're very similar. I used to run the test program for everybody, but the demo program is now cooler than the test program. So we're showing you guys the demo program because it's going to show you a lot of the features that you're going to be using for the rest of the semester. So the test program is just instrumented in such a way that it's easier for me to go through and test boards very quickly, whereas the demo requires a lot more interaction. But the demo for you guys is much more interesting, so that's what we're using. So the last thing that you were commanded to do was press SW0 to go on to the next test. So the next prompt is, it'll tell you to press SW0 again to start, and it tells you optionally open Moo's plotter window. I should change that to say, damn it, open Moo's plotter window, because that's what you want to do at this point. And it tells you to rotate the pot, so we'll deal with that next. So I press the plotter button, and it splits the screen again horizontally, so I'm going to actually hit it right. So you'll see this new window pop up. We were told to actually start this part of the test to press SW0 again. So I'm going to press SW0. And what you'll see over here is you'll see it starting to print out some values. Now, the potentiometer, as pointed out in the documentation, is this guy right here. As you spin this, what you'll see is two things. It's hard for me to hold the camera and do this at the same time. But you'll also, not only will you see the values change over a range as I spin the dial, the potentiometer, you'll also see those values plotted out over here in the plot window. Pretty nice. This is actually one of the reasons why we're using Moo, is not only does Moo have this nice serial window built in, but it also has the ability to plot properly formatted data over in this window if you choose to see it that way. So that is the potentiometer portion of the demo. And the prompt had said, when you're all done, press SW0. If you haven't noticed already, that's a pattern. SW0 is pretty much the button we use to sequence through the tests. So the next subtest is twist the encoder knob in both directions, then SW0 to continue. There's that SW0 again, getting a lot of action. So this is the encoder knob. It's called a rotary encoder. It is a nice clicky knob like you'd find on like a stereo, car stereo or home stereo. And if you'll notice, when you twist it, you'll see the values, depending on which direction you twist it, go up and down. You'll also see the upness and the downness of that count get plotted out over here in the window. And if you'll notice, it's kind of jaggy. If you paid attention to the potentiometer graph, you'll notice that it wasn't. Remember that because you'll be asked about it in the later portion of the lab, and you'll have to perhaps hypothesize why that is. So that's pretty much on how the encoder works. To go on to the next part of the test, you just hit SW0 again. And the next part of the test is push the encoder switch to continue or SW0 to skip/abort. Now, the reason why this message is a little more ambiguous than the other ones is the version 1.1, the new version of the kit, when you press down on this knob, there's a button. You'll feel it click. Just like if it were a stereo button, it would go on and off. Or it would maybe switch you between modes depending on how your car stereo works. The version 1.0 of the kit, even though it has all the same hardware, including the clicky knob is not wired to the rest of the kit. So the clicky knob, the clicky rotary encoder button actually doesn't do anything on the 1.0 version of the kit. But don't feel bad, version 1.0 people of the kit. You have something that the 1.1 people have. So don't feel like you've been left out here or excluded. So we're still at this point in the lab, and all it says is press the knob, which I did, and sure enough, it advanced to the next part of the test. So the next part of the, I keep on saying test, it's a demo now. The test is a different program, very similar to this one. So it says press SW0 to start, wave your hand slowly over the ALS sensor, press SW0 to continue. So ALS stands for ambient light sensor, and the location of the sensor is, let me find something plastic to use to point out. Here we go. The ambient light sensor is right here on the board. It's kind of halfway up, right next to the square thing, which you'll learn soon is the speaker. So I'm going to go ahead and I'm going to start the test by pressing SW0, and we're going to look and see what it's doing over here on the display. You'll see it's happens to be with the amount of light I have here. It's bouncing back and forth right around 0.1, maybe plus or minus 50 thousandths. So, and if you look over here on the graph, you'll see it wiggling up and down. So this is kind of a neat thing. You'll learn more about things like this in ME106. But the reason why it's wiggling up and down and not just a straight flat line like a dead patient on an EKG machine is because I happen to be using a fluorescent light. Now, fluorescent lights are notorious for flickering at the same frequency of the line voltage in the wall, which is 60 hertz. In fact, it's 120 megahertz, or 120 hertz, if you consider both the positive and negative going parts of the sine wave. So what you're seeing here is an artifact of the sampling at periodic intervals of the time when the fluorescent light is flashing on and off. Even though you can't see it because 60 hertz is faster than the eye can perceive, guess what? A microcontroller runs a heck of a lot faster than that, and it sees what these differences are. So there'll be a lot more fun information like that to learn about in ME106, but suffice it to say that if this kit were in daylight, you would see a flat line here. So as you were instructed in the previous message, it tells you to wave your hand over the sensor. I'm going to show you how to do that, like you couldn't figure it out yourself. But what you will see is you'll see proof positive that as I move my hand over the kit, it goes dark and then it goes light again. If I had an even brighter light source, I don't have my flashlight with me, but if I shone a flashlight right on that sensor, the value would go up towards 1. If you are in a pretty low light room and basically kind of mostly dark, and you don't have a good point light source, you're going to have to get something like a flashlight or the backlight on your cell phone or the backlight on your laptop, and you can either pick up your kit and point it towards that light source, or you can bring the light source closer to the light sensor. But regardless, you should see those values flop around. In fact, let me just go ahead and do that. Yeah, you can see as I moved it closer to the light that's shining on the kit, you could see it get brighter. So that's it for the light sensor. It's kind of one of the more fun sensors on the board. Okay, so I'm going to press SW0 to go on to the next part of the test. And it says press SW0 to start printing the temperature, then again to continue. So the temperature sensor is, let me get my plastic pointy device. The temperature sensor is in the upper left-hand corner of this board. That's it there. It's got 3 pins. I know that the inclination is to stick your finger on that chip to warm it up. When we were using a larger chip on the previous Arduino kits, the board or the integrated circuit was big enough, you could actually do that. and not short out any of the pins that were around it. But this chip is so small that it's pretty much impossible to put your finger on it such that it doesn't connect passively, kind of, the 2 or more of the pins that are on this chip. So in line with the safe kit handling instructions that you already read before you got to this point, avoid the urge to press on the temperature sensor. However, what you can do is, if you are in a cool enough room, you can just breathe on the sensor, and it'll be able to pick up the temperature fluctuations. So I'm going to go ahead and I'm going to press SW0 to go ahead and start running the temperature test. And you can see that it's printing out kind of 2 sets of values. The number in parentheses, because it's formatted like that, is actually the one that's being plotted over here in the plot window. But I also print out the degrees Celsius too, which is more useful to you and I. So it's telling me right now that the ambient temperature in this room is 26. Now if I was to just blow on the sensor, let's see if it fluctuates enough that we can see the difference. So my breath, it's telling me my breath is cooler than ambient, which I find a little bit strange or a little bit hard to believe, but I'm going to believe the sensor. What else can I say about this? If you're in an environment where your breath temperature is not that different from ambient, you can just breathe more deeply from your diaphragm and force out warmer body temperature air onto the sensor, and you will no doubt see the temperature go up. In fact, I'm going to do it here, see if I can get it to go through the roof. There we go. That's a pretty notable difference, much more than just breathing on it lightly. And as you can see, as the temperature sensor cools down, it dips back down. So that's it for the temperature sensor test. I'm going to go ahead and I'm going to press SW0 again. Now, I don't know if you heard that because I talked over part of it, but the little speaker played a tune once you press the SW0 button to quit the temperature sensor test. So the speaker is, get my pointy, the speaker is this guy right here. It's this little half-inch, I forget exactly, I think it's 17 millimeters on the side, plastic part. That's a speaker. It is not a hi-fi speaker. You are not going to be playing all your favorite tunes on this, at least not enjoying them anyways. But it's kind of analogous to the type of speaker that might be in something like a microwave oven or some other kitchen appliance. So that's a very short demo of the speaker. Now the last step here, I won't say last, the next step is to use the encoder to move the servo back and forth, and then press the encoder switch to center it and to continue. Sorry about the pulsating focus there. So what it's telling me to do is go ahead and I can move the servo back and forth just by twisting the knob. That's pretty fun. And unfortunately, if you were to have a laser, which you don't, you would actually see the laser shoot across with the servo as you twist the servo back and forth under the control of the knob. Unfortunately, you don't have a laser, so you're not going to see that. So it also the demo program also happens to print out the degrees, the angle at which the servo is currently pointing, with 90 being the center. All the way to the left is 0, and all the way to the right is 180, roughly. And I guess I don't plot it out here because it's not, the data isn't formatted in the magic format that Moo picks it up and plots it out over here. So that's pretty cool. So I should note that at this point, this is a difference in behavior of the 1.0 kit versus the 1.1 kit. So we're going to take a detour right now, and I'm going to show you what this looks like on the 1.0 kit. So on the 1.0 kit, I'm going to put the camera up here, hopefully center it. So the 1.0 version of the kit actually had this servo laser pointer combo mounted on a different board, and their boards have 3 buttons on them for kind of simplifying using the buttons here to actually pan the laser pointer back and forth. We'll show you that here once I power this thing up. Okay, so right now it's going through its demo from the beginning. I'm just gonna hit these things and skip forward through all the tests to get to that point, assuming I can even tell what that point is. So okay, that was the speaker test, which was just before the servo test. Okay, so here we go. So if you are running the servo test on the version 1 kit and you modified your code.py as described in the documentation for the warm-up lab, the way this demo works is all you do is you press the left button to move the servo to the left, you press the right button to move the servo to the right, and then the middle top button centers the servo and advances see, it doesn't respond anymore. It advances the test to the next part. So when version 1.0 people are running their version of the demo, this is what you're instructed to do versus the rest of the students that have the 1.1 kit. So you may be asking yourself, hey, I got a 1.1 kit. Why do I only have 2 push buttons over here and the version 1.1 or version 1.0 people have 3 buttons on theirs? Well, it turns out that these 2 buttons are actually the same as 2 of the buttons that are over here, and there's only 1 additional button functionally on the version 1.0 of the kit. And the reason why they are like this is to facilitate being able to do a sentry gun example. You can move left and right and then use this to shoot. It's a lab we often do later in the semester. I'm not sure if it's going to work out that we're going to do that this semester or not, but that's the reason why I put extra buttons on the previous version of the kit, was to make it a little bit easier to be able to do that type of demo. So if you're a 1.1 kit holder and we do that exercise, what you're probably going to be doing is using the left and right buttons here to move the servo back and forth, and using the button that's built into your encoder shaft to actually do the firing. So you'll be able to go left, 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 right, 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 and then fire. I plan on posting a separate video. There may already be one under the same YouTube account showing a very similar demo either on this kit from last semester or on the previous kits we used in past many years that shows the equivalent Pew Pew demo being run on the Arduino kits. So we're kind of back from our detour of how the 1.0 kit worked. And so that was actually the last piece of hardware to demo on either kit. That was the last demo component. So what you've seen in summary is you've seen everything that's on this kit being exercised one way or another. You've seen the 2 push buttons. You've seen the red, green, blue LED between them. You've seen the red LEDs that are above each of the push buttons. You've seen the jumper that you use to switch back and forth between the red LEDs and the red, green, blue LED. You have seen how the temperature sensor works. You've seen the ambient light sensor. You've heard the speaker. You've played with the knob. You've played with the potentiometer dial. You've seen the servo work. And on my kit, you've seen the laser pointer work, which, yes, it's sad you guys don't have the laser pointer. So that is it for the kit walkthrough. Hopefully between the contents of this video and the write-up for the Lab9 warm-up, you have proved yourselves that your kit is all working just fine. And now you're ready to continue on to the part of the lab that you actually start writing and modifying code of your own on your kit, on your laptop with your software. And that's what you'll be turning in whenever it's due, probably the week after spring break. So I hope you enjoyed the video. Sorry for its craptastic quality, but this is all we have to work with right now, given these strange times we're in. Hope you enjoyed it. See you later.